Hello everyone, welcome to my presentation. I am Neeraj Kumar from CSCB section. Today we are going to discuss presentation on Python memory management in Python. Python, an easy programming language which is used to develop any software, any application, or which is used to develop any web page. Today we are going to discuss how memory is stored and managed in Python or using Python. Memory management in Python. Understanding memory allocation is important to any software developer, as writing efficient code means writing a memory efficient code. Memory allocation can be defined as allocating a block of space in the computer memory to a program. In Python, memory allocation and deallocation method is automatic, as the Python developers created a garbage collector for Python so that the user does not have to do manual garbage collection. Garbage collection. It is a process in which the interpreter frees up the memory when not in use to make it available for other objects. Assume a case where no reference is pointing to an object in memory, that is, it is not in use, so that virtual machine has a garbage collector that automatically deletes that object from a heap memory. Blocks of memory are managed by Python Memory Manager. The pool is made up of a group of identical blocks, arenas, created pools, which are 256 KB memory chunks allocated to heap equal to 64 pools. If the objects are destroyed, the memory manager creates a new object of the same size to take their place. Allocating a block of memory in a computer to a program is also known as memory allocation. Python's memory allocation and deallocation method are fully automated, thanks to the Python developers' creation of a garbage collector that eliminates the need for manual garbage collection. Python manages memory with dynamic typing and a combination of reference counting and cycle detecting garbage collector. It also has late binding, dynamic name resolution, which binds method and variable names during program execution. As we all know, whenever we run an application, it is loaded into run and USA locates some memory to it. The same is depicted in figure 1. Now, figure 2 shows the different area created in the allocated memory for running the application. Raw memory allocator, lowest level memory manager in Python. Interact with memory manager of operating system or OS. Make sure that enough space is available in private heap to store Python related data. Object specific alligator works on same heap. Handle the peculiarities of memory management policies adopted by different objects in Python. PVM, it is also known as Python Virtual Machine. There are two parts of memory in Python, stack memory and heap memory. Work of stack memory. The allocation happens on contiguous blocks of memory. We call it stack memory allocation because the allocation happens in the function called stack. The size of memory to be allocated is known as to the compiler, and whenever a function is called, its variable gets memory allocated on the stack. It is the memory that is only needed inside a particular function or method call. When a function is called, it is added on the program's call stack. Any local memory assignments such as variable initialization inside the particular functions are stored temporarily on the function call stack, where it is deleted once the function returns and the call stack moves on to the next task. This allocation onto a contiguous block of memory is handled by the compiler using predefined routines, and developers do not need to worry about it. Work of heap memory. The memory is allocated during the execution of instructions written by program. Note that the name heap has nothing to do with the heap data structure. It is called heap because it is a pile of memory space available to programmers to allocate it and deallocate. The variables are needed outside of method or function calls or are shared within multiple functions globally are stored in heap memory. Memory management in Python involves a private heap space, all Python objects and data structures. The management of this private heap is ensured internally by the Python memory manager. The Python memory manager has different components which deal with various dynamic storage management aspects like sharing, segmentation, pre-allocation, or caching. At the lowest level, a row memory allocator ensures that there is enough room in the private heap for storing all Python related data by interacting with the memory manager of the operating system. On top of the raw memory allocators, several object-specific allocators operate on the same heap and implement distinct memory management policies adapted to the peculiarities of every object type. For example, integer objects are managed differently within the heap than strings, tuples, or dictionaries because integers imply different storage requirements and speed or space trade-offs. The Python memory manager thus delegates some of the work to the object-specific allocators but ensures that the latter operate within the bounds of private key. It is important to understand that the management of the Python heap is performed by the interpreter itself and that the user has no control over it. Even if they regularly manipulate object pointers to memory blocks inside that heap, the allocation of heap space for Python objects and other internal buffers is performed on demand by the Python memory manager through the Python API functions listed in the document. There are four types of areas in Python memory manager. They are code area, stack area, heap area, and variable area. Code area. This area is fixed in size and code is located here. Stack area. It has the ability to grow and shrink dynamically and it determines the order in which methods are reused. Matplotlib is the most common way to build a stacked area chart with Python. The examples below show start by explaining the basics of the stack plot function. They also describe the most common type of customization like changing colors, controlling group, order, and more. Heap area. Here object gets stored in random order. Variable area. In this section, variables are stored and they refer their corresponding order in heap area. Implementation of Python language. There are some most common implementations of Python are available. First one is CPython. CPython is a reference implementation of the Python programming language written in C and Python. CPython is the default and most widely used in implementation of the Python language. CPython can be defined as both an interpreter and a compiler as it compiles Python code into bytecode before interpreting it. Jython. Jython is a Java implementation of Python that combines impressive power with clarity. Jython is freely available for both commercial and non-commercial use. PyPL is also known as Python Package Index, is a repository of software for the Python programming language. PyPL helps you find the install software developed and shared by the Python community. Ruby Python. Ruby is a dynamic, open source, object oriented, and reflective programming language. Python is a simple, easy to learn, powerful, high level, and object oriented programming language. It is an interpreted scripting language also. Stackless Python or Stackless is a Python programming language interpreter, so named because it avoids depending on the C call stack for its own stack. In practice, stackless Python uses the C stack, but the stack is cleared between function calls. Anaconda Python. Anaconda is a distribution of Python and R programming languages for scientific computing, data science, machine learning applications, large-scale data processing, predictive analytics, etc. that aims to simplify package management and development. Deployment. Anaconda Python is a collection of a number of very useful Python development packages as well as an interpreter. We will use the IDLE editor to build and run Python programs. IDLE is included as part of the Anaconda Python installation. Anaconda is the best tool in processing a large amount of data for the required purpose. Anaconda is a Python distribution that is commonly used for data science. Anaconda Navigator is a GUI tool that is included in Anaconda distribution and makes it easy to configure, install, and launch tools such as J- Jupyter Notebook. That's all for now, friends. Hope you enjoyed my presentation, and I think you gained a bit of knowledge regarding Python and memory management in Python and implementation of Python in different programming languages. Thank you.